Let me make sure you're in focus. And
welcome back. This is lesson 88, continuing our discussion of proportionality and proportional relationships. It's often important to determine, are we dealing with a proportion or not? So this is a review of what's proportional and what isn't. To be proportional, and remember this is a yes or no question, 3 things have to happen, all right? The first is that we're talking about 2 variables, all right? Typically x and y, or we could talk about time and distance. We can talk about hours worked and the amount of money. 2 things that have a relationship together. But the important part about that relationship is that as one variable changes, the other changes by what we call a constant factor. This constant factor gets the letter K in algebra, and it means that we're talking about a number, something that does not change, does not vary, so that it's not a variable, it is a constant. So it changes by a constant factor. And if we have our 2 variables as x and y, which could represent just about anything, if these are in a proportional relationship, then the value of y will be equal to the constant factor, the same number, times whatever x is. All right? This is a ratio of proportionality here, or this is a factor, right? Constant factor means it's being multiplied. So it has this relationship, and we can use that relationship to understand whether or not we're dealing with a proportion or not. Because in this sense, we have a constant factor, a multiplication problem, but we can solve for k, get k all by itself, by dividing both sides by x. X's cancel out, and we see that this constant factor of proportionality will always be the same number if you take whatever y is and divide it by whatever the x that goes with it should give you the same number. All right? That's the first thing. Second thing, to be a proportion, all the pairs in a table of values, sign of the cross for example, must form a constant ratio. All right? In other words, if we take whatever the y side is and divide it by whatever the x side is, you should always get the same number. That will tell you that yes, that is a proportion. So for example here, if we take this and we do y divided by x, and be careful, don't mix those up, all right? It's always y divided by x. Here we see, nonsense, because we've got that as in the denominator. But 6 divided by 3 is 2. 8 divided by 4, what do you know, is 2. 20 divided by 10 is 2. And that means we say that 2 is that constant factor. If these numbers don't divide that way and always make the same number, then it's not a proportional relationship. Finally, number 3. If you graph a proportional relationship, x and y axis, all right, 2 things have to happen for it to be proportional. It's always going to be a straight line. It's always going to make a linear relationship, and that straight line has to go through the origin, 0, 0, right, the origin. So for example, here we have lines A, B, and C, and they all show a proportional relationship. However, if I draw a line here, say D, this is linear, yes, but it does not go through the origin down here, right? Remember, that's the origin. And if it doesn't go through the origin, this is not proportional. All right? So 3 things, all right? They have to change by a constant rate. That constant rate can be found by dividing one by the other. And they must be linear and go through the origin. All right? So take a look at these types of problems. All right? In geometry, we use a scale factor. All right? Multiplying to get a bigger thing, to dilate something. All right? So here we take a look at these relationships using a scale factor on a square. All right. Here we start off with 2 by 2, a square. Then we use a scale factor of 1.5, multiply each side by the scale factor, 1.5, and now you've got a square that's 3 by 3. If I had a scale factor of 2, then I would multiply each side by 2, and now I've got a square of 4 by 4. Now the question is the perimeter or the area or both a proportional relationship? And the way you do that is by looking at the relationship here. The side, L, what changes, what we can do, that's X, and the perimeter, what we get when we change something, that's Y. So we look at the relationship, the ratio of perimeter to length, and we see that this is 8 divided by 2, which is 4. Here, the perimeter of this is 3 times 4, 12. So 12 divided by the side length 3 is 4. And here, 4 by 4 is a perimeter of 16. Divided by 4, what do you know? You get 4. And so we say that this is, yes, a proportional relationship between side and perimeter. Over here, we'll see if it's the same relationship. Here now we compare the area of the square, length times width, to its side length. And we see that we have 4 divided by 2, that's 2. 9 divided by 3, now it's 3. 16 divided by 4, now it's 4. We do not see a constant factor here. We do not have the same number when we do the division. So here we say the answer is not proportional. Right? You're being asked a yes or no question here. Do these things show a proportional relationship? All right. We can do it by equations. All right. In other words, this C, all right, what it's solved for, that's just like being y. And pi is always the same, that's k. And d, that would be like x. And the question is that a proportional relationship? And you should understand that, yeah, that is definitely in the form of y equals kx. Another test you can use is that if x equals 0, does y also equal 0? Because if it doesn't, then it's not going to go through the origin. In this case, it does. So we say, yes, this is a proportional relationship. Over here, we see that now we've got kind of the same thing. That is a constant, all right? But here we see that x is squared. And the ratio squared means it is not in a line. It's not linear. And so we will not have a constant ratio. And you could do that by quickly creating a radius and area. And so here, if the radius is 1, the area is pi r. If the radius is 2, or just pi, the radius is 1, then the area is pi. If the radius is 2, now you've got pi times 4. If the radius is 3, you got pi times 9. These do not form a constant factor, constant ratio, constant k. And so this is not proportional. Over here, we look at this, and again, using the test of making x equal to 0 and seeing does y equal 0. Well, here, if x equals 0, y is going to equal 1. If we were to graph this, it would look like that. Not through the origin, not proportional. These are tests that you can use. Other types of problems you might see would be something like this. Can this be solved using a proportion? All right. 2 workers complete the job in 5 hours. How long for 4 workers? All right. If we tried to do this with the sign of the cross, and we would say that we've got 2 workers in 5 hours, then how long for 4 workers? 4 workers for how many hours? if it was proportional, this would work. Now, thinking about this, if you've got twice as many workers, how long should it take? Should it take more or should it take less time? Right? You would think that if you increase the number of workers, the amount of time is going to go down. But if you treat this as a proportion, you see that you would have 2 over 5 equals 4 over something. Oh, okay, so that's 20 divided by 2. So the amount of time is not 5 hours anymore. Now it's going to take twice as long, 10 hours. For twice as many people? I don't think so. This tells you that this is not a proportional relationship. Okay? Here's another example. Each student reads the same number of books. 30 students read 150 books. How many read by 60 students? Well, the key here is the same number of books, all right? It's implying that there is some proportionality constant here. If I read 2 books, then everybody else read 2 books, all right? And so if I have 10 students and each read 2 books, it'd go up to 20. If I had 30 students, then it'd be 60, and so on. So we can see that we suspect this is a proportion, but we can test it out, all right? We can say that the idea of 30 students, 150 books, goes with 60 students would be how many books? Well, you can double that and you get 300 books, and it definitely works. So this is a sign, and the answer would be yes. All right? The idea of proportions and proportionality. I mean, last time we talked about scale, all right, a scale drawing. This time we talk about identifying how to deal with it. If it's a proportion, we know how to deal with it, all right? In our next lesson, we'll talk about the scale factor and its relationship to geometry. So for this, all right, please do lesson 88, and this is task number 2, A to F. And I hope you're getting something out of this.